Next, we have Major Jiang, PhD, research scientist at IMAX Labs, and he's going to be talking about LMM frameworks for per-title video encoding optimization. So thank you, Major.
Okay, thanks, Chris. So can you see my slides here?
Yes.
Cool. So the topic I'm going to give is large multi-modal model-based video encoding optimization. We submitted this paper to like IBC this year. So let's start with the problem definition. Let's focus on what kind of problem we're trying to solve here. So I'm going to show you a demo, like which consists of like 2 video clips. They are the video segments from the same video encoded using the same configuration at a bitrate of 7 megabytes. You can see, like especially on the left, the IMAX CPS score is like 61, which is really low, and for the right part is like 92. Let's go through it again, and you can see lots of distortions on the left, like the blockness, distortions on the surface of water, and the building, the blockness distortion on the building caused by the fast-moving camera. And on the right, you may like observe some like distortion on the people's skins here. So this kind of problem caused by like using the same configuration to encode the whole video. And the typical solution is like a one-size-fits-all approach. And the table you are looking at is like the ladder used by Netflix. We can see like for us target bitrates, they have like a specific resolution for each of them. And there are some drawbacks of using like a one-size-fits-all approach. First is suboptimal quality, which means like all the users, all the consumers, they will view the content encoded at the same like resolution and bitrate, and due to the complexity and the cost, because you have to prepare like different encoding for different bitrate and resolution, and for the inconsistent quality, because like we know, like if you watch the same content on like for example like a TV or cell phone, like even they have the same encoding config, you have like different viewing experience. And of course, the scalability issues, which like you have to maintain a large library of all these like ladders for different bitrate and resolutions. That's why we have like nowadays we have like a alternative solution, which is per-title optimization. Like so you can see the workflow here. So we have the source video. We like encoded it using different configurations, and we analyze, we evaluate the quality of each encoded configurations, and we do this again and again and again, try to find the RD curve, which is the rate distortion curve. And with the rate distortion curve for different resolutions, we can, if we are given like a target bitrate, we can select the best encoding configuration with the highest like a score, real score, which is like IMAX APS here. So although like there are lots of advantages using like a per-title optimization, especially like increasing the viewer's experience, there's still some drawbacks here. So first, like the per-title optimization only focuses on optimizing the config on each individual content, each individual video. So it lacks advanced video understanding capabilities. For example, like scene change and like some content-aware like features and objective tracking, and also like the most cost thing is like the content, the per-title optimization only focuses on each content, and each requires repetitive sampling, which means like lots of encodings. And for some companies, they cannot afford such a like a cost to encode like for example like dozens of samples to predict the quality curve. So that's why also has like a high computational cost. And with like different encoding configs and all this data we have, you have to maintain this content library, which causes like the scalability issues. And that's why we're focusing on this project. We're focusing on to follow the pattern of per title optimization, but we want to reduce like the encoding costs, like sampling costs. And given the advantage of large multimodal achieved, for example, I guess everyone nowadays are using like Copilot, like Gemini from Google and ChatGPT from OpenAI. So we can see like how like LM models can help in like understanding like videos, images, and audios as well. So we'd like to integrate these LMM models with per title optimization for superior video encoding and reduce the cost while increasing the viewer's experience. And the workflow we prepare is to replace this repetitive sampling and with LM content analysis. Sorry. And with LM models, we can extract some semantic information from each like a source video. So this is our like the workflow proposed by the enhanced LMM per title encoding. So with the source video as input, we use the LM model to analyze the features, the information of this of each video, and we get the semantic information from this video. Then we already prepared a database which has like RD curves and LM features for like videos in this data set. And we try to use the KNN to predict the RD curves, use the semantic information from the source video and all the like information from our database. And then after we predict the RD curve, we can compare it with the anchor profile and gives with optimized encoding config. So let me give you like some demos here. Let's look again, watch again of this like horrible example. Lots of distortions, and I'm definitely not satisfied with like this viewing experience. So after apply the approach we proposed, we have this optimized result. We can see like numerically, we can see the improvement on the IMAX EPS scores, which improved from like 61 to 86 to the left side of the video, and we can see like 2 points gain to the right side of video because like the right side of the video already has like a really good quality. And from my personal opinion, like I could not observe some like distortions on the left side. And also like on the right side, I can hardly see like any distortions on these people's skins anymore. Yeah, so that's about like this AI-powered, LM-powered per title optimization. So I'm happy to answer any questions from you guys.
Yeah. Hey, Major. Quick question.
Okay.
I was trying to understand, like, after you run the LLM, is it telling you per segment what the encoder setting should be? Like, is it breaking it down by like, for this second of the video, you should use these settings, and then for the next setting, you're using these different settings?
Not really. Let me go back to previous slides. So for the LLM model, it gives us a semantic information. It doesn't give us like any like encoding config we should use. we apply this semantic information and we use this information to predict the RD curve. With the RD curve, we can, like for the target bitrate, we can give you like a encoding configuration. That's why we also need the anchor profile as the input for the per-title optimization here.
Oh, gotcha. So it's still the same config for the whole video. You're using but you're finding the best config that has the best trade-offs, I guess.
Yes, I'm not sure if I answered your question correctly, but like with the features given by we can predict the RD curve, and with the RD curve, actually, with a correct RD curve, we can do anything we want for optimization, because we already have the scores for different bit rates, and for the streaming service, we're focusing on deliver like a better viewers experience on the target bit rate.
Yeah, it makes sense. Thank you.
Thank you.
Major, how long does it take to run through one optimization?
Yeah, we do have some like numbers here I can share with you. For example, like because in the research we tried with different like benchmark approaches as well, and we run this like experiment on AWS EC2 G5 2x large machine like instance. So the proposed like a method takes around 6 seconds to analyze like a 4-second segments. And if we want to use some like other comparison a method, for example, we want to like fit the RD curves, it takes like more than a minute, like 84 seconds. And for some other methods, though they have like faster, they take less time for the computation, but like the results, bit receiving results are not as good as the proposed like method. So like you're looking at just the computing time for like a 4-second segment.
Cool. Any other questions? Okay. Well, thank you, Major. That was great. I appreciate both you and Hojat being able to join in such short notice, but it's nice to run one of these again. And I know there's a Montevideo tech meetup happening October 3rd. If you're interested, I can provide the meetup link for that. That's been pretty good. I've attended a couple of those online. They've actually, one of the neat things with the Montevideo group that's in Paraguay, that they've been trying to run a summer meetup program, and the summer meetup program in Uruguay, it's our winter. So they've had a bunch of people from all across the industry join, and Nicholas, the person who runs the group, he's presented here previously earlier this year. So I don't remember what exactly the topic is for this upcoming one, but they're going to be talking about possible projects for the summer camp. So yep, that's October 3rd. But I think most people from IMAX are going to be busy that day, but it's still good to watch that. And then DMUX is coming up in 2 weeks, 3 weeks now. So there's lots of engineering related talks there. And probably not going to run one in October, but I'm trying to track down someone to do a November talk, and hopefully that'll be interesting. So see all of you in a couple months. Okay. Great. Thanks, everyone. Cheers.
Thank you.
Thank you.